Hello, everyone. Very glad to be here today. So we're going to talk about building a RAG for a medical company. And we will both talk about the technical and product challenges. So with a quick show of hands, who here is familiar with RAG? That's great. Just to make sure I have the right level for the talk. I see there are basically pretty much half of the room who does not really know it, so I will try to cover the basics as well. So very quickly about myself. I'm an engineering manager and the GenAI leader at Sicara. It's part of the Theodore Group. It's a service company building data science and data engineering products for their clients. And from my experience, I first worked as a data scientist for 6 months in OCR and adverts in a company called Realytics. And then I've been working at Sicara for 3.5 years. Some projects I did, just to give you a quick idea. So a lot in vision with object detection videos, matching to similar products. So it was already a lot of vector databases before the GenAI hype. Risk detection in all platforms, a RAG for a medical company, which we are going to talk about, and error detection in invoices, which is another GenAI use case. So the VDAL, which is basically our source documents for this project, it's a company. It's very weird because we don't see the picture on the left. Okay, now it's better. So the VDAL, it's basically the reference for medical knowledge for all health professionals in France. So it's not really well known here in Berlin, but in France, if you're basically over 30, 40 years old, you will see it on all the doctors' shelves. It's a red book, where they are basically looking for dosage, secondary effects, and stuff like this. So it's been around for a while. There are a lot of users, mostly professional users. It's in a lot of countries, and there are over 30,000 monographs. So a monograph is a document which says for a given drug what are the secondary effects, what is the dosage, etc., etc. So we just asked this question, and now let's do a quick demo. Just as a quick disclaimer for the demo and all these presentations, basically in the code, all the documents and the prompts are in French, but basically I used Google Translate on the website and on everything that's going to come afterwards, so it looks like it's in English. But basically, so if I come here and I say something, how long should I stop Eliquis before operation? So Eliquis is a drug. So imagine you're a doctor, you have someone coming to you who has a question about doing an operation because he broke his hand or something and is under some drug, and you want to make sure you are allowed to stop it before actually operating the person. So you will ask the question, you will see the documents which will be found. Because basically in the VDAL, so in the 30,000 reference monograph, it will find the documents which look the most similar. So this is the first part of RAG, which is retrieval, finding the most similar documents. And I feel like the connection is not great, but it's finally working. And it will find the documents. And then on the documents, it will try to answer the question. So here, the answer is not great, but I assume it's due to Google Translate. Then from the official source, so here it's from the VDAL, you can see highlighted in yellow the apixaban, so which is the medical name for Eliquis here. It needs to be stopped 48 hours before a surgery, so you know you need to stop this drug before actually operating your patient. And if I just show you as well the demo I prepared, which is very similar. It's just to show you that the AI also formulates an answer, but like since the page is transcribed live with Google Translate, sometimes there are some problems. I think I'm just gonna go on my phone for the Wi-Fi. So yeah, here where you can see that the AI formulates an answer, a pick savant should be discontinued, etc. But since the answer is generated with AI, you know, there can be a lot of hallucinations, etc. It's very important to also base it on a proper document and highlight in yellow the answer so that you know where to look. So this is basically the end product. Now we're going to look at how we build it. So a little bit of theory. This is a monograph. So it's a document which can be over 40 pages with a lot of information. So it's for the Presista, which is a drug. I don't know for which, which kind of sickness. But you can see it's very long. Here you can see the small slider here. So yes. So finding the right information in such documents can take quite a while. And there are, for the same drug, there can be a lot of monographs because there can be a lot of like derivatives, which all contain different information. Because for the same active ingredient, you have the generic name and the brand name. You have the brand name is basically the main one, and then the generic name is all the derivatives that comes out of the main drug. We have the dosage form, so do I eat it, do I drink it, etc., etc. And all these combinations leads to a different monograph. As we saw, a monograph can be very long. This is why finding the right information in these documents can take over 3 minutes to a doctor. It's not that long, 3 minutes. But when you know, when you go to the doctor, it's, in France, it takes around 10-15 minutes. The fact that they spend so much time finding the right information instead of focusing on the patients can be a problem. So our first thought to do such thing is, can we just do it with ChatGPT? So it does work. How long should I stop a keys before an operation? It provides the good answer in 30 seconds. There is a lot of useless text, which makes it basically longer to read. And more importantly, there is no sources provided. We know generative data is subject to hallucinations. So a doctor cannot use it to basically give a drug to a patient. So we can use retrieval augmented generation. So retrieval augmented generation is really from a base of documents retrieving the right information, which is what we saw in the demo we did. So we are retrieving the documents on LLMs, and then from these documents, asking the question of the user. Asking the question of the user on these documents to answer the question. So with Qdrant, which is a retrieval augmented generation solution off the shelf, so you just drag and drop your documents, and then you can see inside the document which allows to answer. It gives a good answer in 30 seconds, and the answer can be customized as well. So it seems quite good, but is it performant enough? So to know if it's performant enough, we started with collecting a data set from real healthcare professionals. So the way we did it is during our user interviews at the start of the project to validate our convictions. We also asked them, what kind of search did you do in the past week in the Vidal, to basically collect a data set of 100 questions that the doctor asked themselves over the week. So this is really for evaluation purposes. We are not going to train on 100 questions. It's not that big, but it's a good place to start. So this is an example of a user questions. Are the side effects of clamoxyl in liquid form and in capsule form the same? I'm not a medical expert. I'm not really sure what clamoxyl is, but really what the user is asking here is, are the different forms the same? It took 30 minutes and 16 seconds to the doctor to find the information in the Vidal. The answer obtained was yes. And here are the monographs he used, which contains a part of the answer. So then we are going to define a metric. So we have a question. It goes through our copilot. It gives an answer. And we define 3 labels. Okay, if a doctor, which will help us to validate our results, considers it's okay. I don't know if the system specifically says, from all the information you have given me, I haven't found anything relevant. So it's really in the prompt, you specify that. You can just say, if you don't find anything in the document provided, just say you don't know. And KO, if the model says consult a doctor, because it does not make sense to say consult a doctor if you're already a healthcare professional, if it's a false information or an incomplete information. And our initial objective was to have 0 KO questions out of these 100 questions, and the least I don't know answers. So this is the architecture we used initially. And this is basically a typical architecture for an off-the-shelf RAG, where you have your monographs, so you have your documents. Then you're going to split your documents in a quite random way. So there are different methods. We took kind of a dummy one to start with, where we just, every 8,000 tokens, we will split the documents. Because we are using OpenAI ADA, an embedding model, and the limits of this model was 8,000 tokens. We put it in a vector database. We're using Qdrant. It's one I really like. It's actually based here in Berlin because it's both open source and managed. You use the same client for your experiments and for deployment, so it has a lot of advantages. And then a healthcare professional in consultation asks questions about the medicaments. They will write their question in the search bar. The question will go through the embedding model. So basically, the embedding model is a model that represents, give a vectorial representation of the question. The same way it will give a vectorial representation of all the subparts of documents you will have in the Vidal. And then you will compare the representation of your questions to all the representation of the subpart of the Vidal to retrieve the most similar documents. So the most similar chunks of the Vidal, with basically the one which are relevant to answer your question. You put them all in a prompt and then ask GPT-4 Turbo to, from these documents, answer my question with a prompt saying, you're addressing health professionals. If you don't find any information, say you don't know, etc., etc. So this is the performance we have at the beginning. So it's not too bad, considering we haven't put any specificities in it. So we really took a dummy thing. But so we have 40% of right answer and 20% of answers we are judging as KO. But it's definitely not enough to bring value to in production to users which are health professionals. So just checking the time. Cool. Here's an example of a KO answer from our datasets. Are the side effects of clamoxyl in liquid form and capsule form the same? So this is a question we just read. So as we can see, the model says it's important to consult the leaflet or a healthcare professional, which is something we don't want. And also, among the sources retrieved, we retrieve sources on clamoxyl in the capsule form. We can see it here. But we don't see anything, there is no sources retrieved about clamoxyl in liquid form. So we cannot give a complete answer to this question because there is not all the documents we need to answer this question. So the answer is incomplete. This is an example of a don't know question. What precautions should be taken when prescribing Detensiel for diabetic patients? You can see that among all the sources, none of them corresponds to Detensiel or anything relevant to the question. So the model just answers, I have not found any relevant information. Could you provide more context or rephrase the question? So the model specifically says it doesn't know. And finally, an OK question. So this is about tablets of propanolol. And it found the right sources to answer the question, and the answer it has given is actually good according to a doctor. So once this initial model is created, we can already ship it to build a prototype, which will be used by beta users to start gathering their first thoughts on the tool. So to retrieve to monitor this prototype, we used Langsmith, which can be really easily deployed. It does not have to be used with LangChain if you're not a fan of the tool. But Langsmith is really complete, really great. It allows to basically every row you see here corresponds to a user interaction, and when you click on a specific row, you can see all the model interaction which happened. So here there was first a model which rephrased the question. Then we had some similarity search. Then another model which answered the final question. And what's great in Langsmith is that you have this button called the playground, which allows to replay a prompt. And this is really great because you can actually put this into the hand of a business, collaborator, which will be able to iterate on the prompt engineering. Because as I already specified, I'm really not an expert of medical knowledge. So while our product owner was really an expert in it, so allowing this person to play with the prompts was a major plus for the project, as we will see in a couple of minutes. Performance, we will try to raise it. So the first thing we can see is that as we saw, we use a naive segmentation of chunks. So again, here, before putting the documents into the embedding model, which will create the vectorial representation, we need to split it in subparts because there is a context limit in the embedding model. So the thing is that since we just splitted it every 8,000 tokens, sometimes the start of the section was missing. So here it starts with the end of the section on fertility, pregnancy, and breastfeeding. Then it contains a section on driving and using machinery, and only contains the start of the side effects. And the end section of side effect is also missing. So you don't get the entire information. The other problem with that is that it's not only that the information is split in the middle, is that the embedding, so the vectorial representation, it will try to represent something which is a bit on fertility, something which is a bit on driving and using machinery, and something which is a bit on side effects. So it will be basically the ending vector in the semantic space will be somewhere in between all this section, and it will be neither close to a question on machinery or a question on side effects. It will be a bit far from everything. So what we did is that since we know how the HTML works, of course, it wasn't that easy because the data quality is not always perfect. But basically, you parse well the HTMLs, you put some custom rules, and then you can decide that all your chunks are always started with the beginning of a section and ending with the end of a section. And on top of that, so you don't have the split problem anymore, but you also, a chunk is one section, so your embedding model will only represent a single section, which means the corresponding embedding will be very close to questions on this specific section. So just doing this, it improved a lot the performance of the model. It reduced the errors by 30%. And if we look, for instance, at the questions which failed earlier, it's not failing anymore. And it managed to retrieve the liquid form of the clamoxyl. And so we have all the information needed to answer this question. So in only 4 weeks, we managed to, data in French, but I hope you can do a bit of translation. It's December and January. In only 4 weeks, we managed to basically reduce all the errors to 0% and drastically reduced the I don't know answers. What we can see is that the largest improvements really happened during the 3rd week. So what happened there? It was a very easy trick. We just added in the prompt. So basically, we added a prompt to reformulate the question. Basically, because sometimes how long stop Eliquis before operations, how long before surgery should you stop taking Eliquis, etc. Rephrasing these questions helped the model. And what we did as well, and this is really what helped improving the performance, is we asked the GPT, when rephrasing the question, to include the international non-proprietary name. Sorry, it's quite hard to pronounce. It's basically paracetamol for Doliprane. I'm not sure if Doliprane is a drug in Germany. It's not, okay. So basically, sometimes you have a drug, and then it's also known by its drug name. Like there is a molecule and the drug name. This is kind of the mapping. Sorry, I won't be able to give any good example in German. But basically, I would never had the idea to do it because I did not know what it was. And it's actually the product owner which thought about this improvement, playing around with Langsmith and the playground, replaying the prompts, and saying it was working well, seeing it was working well. So it tried on a couple of results. It saw it improve it. Then it gives the tips to the data team. We rerun the 100. The battery of tests with all the pipeline, and we see it actually improved the performance. It's actually great because it's the first time that I see a product owner contributing to the R&D operation in such a great way. So it's definitely changing the way we are interacting with each other. Why did it work so well? Because then, if we come here, then although in the prompt we only talk about Eliquis, the retrieval part, here we are adding also the apixaban word. So the retrieval model knows it can output documents about Eliquis or apixaban. Because while we are rephrasing the question with GPT-4 Turbo, while GPT-4 has been trained, is a huge model and has been trained on a lot of data, and so knows how to do the mapping between Eliquis and apixaban, The embedding model is a much smaller model, trained on much less data, and so it may not know how to do this mapping. So basically, we are extracting some knowledge from the LLM to put it in the to help the embedding model. Of course, later on, what we want to do is directly use the Vidal APIs to do this mapping, which will be more resilient, etc. But this was a much easier way and faster way to poke the feature. So after the two improvements we just mentioned, the two changes are that the split of chunks, which is now better, and the reformulation of the question with the I and N. So, of course, there are a lot of other small improvements. I won't go into all of them because we won't have enough time. But at the end, we end up with 88% of OK answers, 12% of I don't know answers. Is it enough to gain adoption? So to ensure that the product is adopted by our users, we rely on the theory of Marty Kagan, which wrote a book called Inspired. Who here is familiar with this book? A few people? So basically, it's Inspired is a lot of theory on product development. It's helped creating some great products in the Silicon Valley, like Dropbox and a lot of others. And it basically highlights 4 risks, which if you don't address one of these risks, your product basically won't work. The first one is value. Basically, does your users perceive value in using your product? So does the doctor perceive a benefit in using it? Usability. Will doctors be able to use the tool? Feasibility. Can we build? Do we have the right resource to build and maintain the product? And the last one is viability. It's basically the business plan. Do you have a business plan? Is this solution viable from a business standpoint? So we will focus on usability and value for the end of this presentation. So starting focusing on usability, will doctors be able to use it? So before building this model, we made 2 assumptions. The first one is that AI is never 100% reliable, so we'll have to cite the sources. And the second one is doctor only trusts reliable sources, so we will need to display the Vidal directly in the tool. So this is what we did at the beginning. So here you can see that it's citing the answers, and you have directly the HTML from the Vidal displayed in the response. The doctors are used to it, so basically the tool will look familiar to them. To build this interface, we used Chainlit. It's a framework that you use with Python, which is very useful. You can basically deploy a chatbot very quickly. And actually, all the front components are built in React. So if you want, you don't have to, but if you want to customize the front end as we did, you can basically reuse the Chainlit React components and basically tune them. And so you have your Python backend and your React frontend, which are interacting with each other to basically compute, do all the right logic and display the right answers. But then, when we put it in the hand of the doctors, the first thing they are telling us is, I don't understand how the tool chooses the sources to give me the answers. Can't I choose? The second thing we noted is that the cited monograph is too long. I can't see where the information is taken from. So what we did to address the first problem is that we made the sources selectables so that the doctors can have some control on the tool, and they know what the answer will be based on. So they can either use to choose a generic or a brand name. So Qdrant and amiodarone. Amiodarone is a generic and Qdrant is a brand name, I think. So it's a derivative from amiodarone. They can use a specific dosage if they want to. For instance, Elikis 2.5 milligram or Elikis 5 milligram. Or they can choose to base their answer on all documents, which is what I did in the demonstration at the beginning. The monograph is too long. I can't see where the information is taken from, which was another feedback. Indeed, here we are citing a single section, but the section can be up to 5 pages, so you don't really know what was used to base your answer on. So we basically decided to highlight in yellow the part of the document which is used to answer the question. And how we did it, so we are using OpenAI functions. So basically we have a prompt which says respond concisely to the question based on the following documents. You put all the documents, and then cite the short passages from the documents on which the answer is based. And basically OpenAI functions allows to retrieve JSON formatted answer, and in the JSON you will ask to have the start of the passage on which the answer is given and the end of the passage. You don't ask it to cite the full thing because then you will waste a lot of tokens. And then it says find the minimum at the start and 2 tablets every day at the end, and then you can just find it in the document and then use some mark tags in the HTML in the front end to highlight it, to highlight the part in yellow. The second focus we had was on the value. So does the doctor perceive a benefit in using the product? So simply we looked at the search time they had. So for instance, for the specific questions, of course here I'm overfitting on specific examples to give concrete examples, but we had also the overview on the entire interviews, of course. Can I use the Lovenox if my patient has a glomerical filtration rate of less than 32? I don't know what it means either, no worries. It took 2 minutes and 42 seconds to the user to find this answer, and they obtained the right answer looking for it. And so we compared it with our search tool. So I typed very slowly to simulate doctors using the... It can take a while. I will fast forward a bit. So first, it's rephrasing the question. So they can choose to base their answer on a specific document or all the documents. Here they are choosing all the documents. And it sometimes takes a while. The streaming is not activated due to a buggy version of OpenAI. But after around 51 seconds, they have their answer. The right information of the VDAL is highlighted for them. So it took around 50 seconds. So it went from 2 minutes and 42 seconds to 50 seconds. So there is definitely a gain when you know they spend 10 minutes with their patients every time. Thank you. So what's next? We still have some feedbacks. It's a new tool. There is a real challenge for doctors to be able to use it. So for instance, we put it in the head on someone else, and they just typed Qdrant. because that's the way, Qdrant is a drug, that's the way they are used to search in the Vidal. They don't know they need to ask a question. So the person was like, oh, I actually need to ask a question. Then we are rephrasing the question because we are basically display the rephrasing of the question just to make sure if it's buggy, then the doctor can see it, etc. But then the reaction was like, does it think I'm an idiot? To save cost also because OpenAI is really, really much cheaper than serving your own model when you don't scale, when you have a few tens or hundreds of query a day. But it's much longer. It's much more expensive when you have thousands of query a day. So we were considering using an open source model. So at the time, it was a few months ago, the state of the art of the open source was Mistral, the mixture of experts of Mistral, and the state of the art of closed source was GPT-4. So comparing basically SOTA and SOTA, we see that Mistral is really not as good as GPT-4, and you really lose the magic of GPT-4. Also, the evaluation is done manually with the help of the doctor, and it really limits the size of the data sets and the frequency of evaluation. So if we want to expand our data set, we need more automatic way to evaluate. So one thing is to set up automatic metrics for retrieval. If we have the documents, stuff like hit rates. I'm short on time, so I will go quickly on that. Or using LLM as a judge for your generation, basically an LLM to evaluate your LLM, but still combining it with some manual evaluation because it can be dodgy sometimes. Since you're using AI to evaluate AI, you can see how it can start to be dodgy. And of course, we need to separate our evaluation and test sets. Here we are just using 100 questions. We need to separate them to make sure we don't overfit in some features which are specific to the evaluation sets. So very quickly on the conclusion, because I'm running out of time, to ensure we build a product that works, we focused on the entire machine learning lifecycle, starting from data preparation, engineering, evaluation, deployment, to monitor and evaluation. I think it's very important to point that out because since poking has become very easy with LLMs, sometimes all the evaluations part and stuff like this kind of go in the bin, so which is why sometimes some products struggle to work well. Thank you very much, and I hope you enjoyed the talk.
Thank you, Noé, for your whole presentation. And thanks to all of you for all your questions you have wrote on Slido. If you don't have a question, just read through them and you can vote them actually up to get them answered first. The first question is, how do you mitigate hallucination and prompt rephrasing? For example, in GPT generates an incorrect INN.
This is a very good question. It actually happens that the INN is not completely wrong, but sometimes there can be some confusion. So at the moment, we are not mitigating it. What we want to do is basically basing ourselves on the API of the Vidal, which contains this mapping, which will make it much more resilient. So just to give some ideas, we did this project a few months ago, and we are going to take it back in a month to basically continue it.
How do you handle the tables in the documents?
So this was one of the performance problems. Actually, the tables were badly handled, and we simply transcribe them to CSV, so comma-separated values. So we just separate them with a comma, since there are never hundreds of columns, but it's more a lot of rows. Actually, GPT is not that bad with if there are only a few columns.
Since you are running on GPT-4, you are probably hosting on Azure. How do you make sure you are GDPR compliant, especially since you are dealing with medical data?
That's a good question. No, basically all this, right now it's only a prototype, so we haven't really given the thought about GDPR. Vidal has already a lot of infrastructure and everything in place to deal with GDPR in the medical context. So this will be really taken into account in the second part of the project.
How do you optimize recall and retrieval if the number of documents increases? What were your findings? What is your total number of documents in your DB?
Again, a great question. So basically, what we saw is that there are still 12% of questions where the model says, I don't know. Actually, all these questions, it's because they are on a lot. It's basically, what are the secondary effects between a list of 10 different drugs. So we can't answer right now these questions. What we are planning to do is basically reusing a tool of the Vidal which already exists, which allows to compare different drugs. And basically, if we identify there are too many drugs, it's usually, it's always actually that kind of questions. So we will basically call this tool, so do an API call to call it, and basically use the LLM to generate the right call for this tool, so that it just, instead of displaying an answer, it displays the interaction comparison tool.
Have you explored integration with patients' records to always inject relevant medical history into queries?
So, sorry, can you go ahead?
Have you explored integration with patient records to always inject relevant medical history into your queries?
No, because it's really, it's something could be done later in time, but it's really something when you have a patient in front of you, and the idea is not to replace the doctor, but kind of to help them. So we want to do something end-to-end, but really just answer simple questions. But it's something that might be done maybe in the future when we want to be more specified on the usage.
There are so many more questions left, but the next tab is coming up. Thank you for answering our questions, Noé.
Thank you.